Hello dear students. So in the previous class we studied regarding the electrical instrument. So we have already studied meter bridge. So today we are going to study one more electrical instrument, that is potentiometer. To recall few things, in the previous class we studied meter bridge, which is an electrical device which is used to measure the value of the unknown resistance. So today we are going to study a new electrical instrument, that is potentiometer. So the name itself suggests potentiometer. Potential means dealing with the potential energy of the electrical circuit, and meter is measurement. So what is potentiometer? It is a device, electrical device. It's not electronic, okay? It's an electrical device which is used to measure potential difference between any 2 points in an electrical circuit. So basically potentiometer is an electrical device which is used to measure the potential difference between any 2 points in an electrical circuit. So when we already have a voltmeter, in your 10th standard you might have studied regarding voltmeter, ammeter and gallonmeter. Ammeter is used to measure the current, voltmeter is used to measure the potential. That itself what potentiometer does. And also you know the gallonmeter, which detects the current. So already when we have a voltmeter, what is the need of this potentiometer? Because if you remember, in 10th standard probably you might have studied a little bit of voltmeter. So basically what is voltmeter? Again, it's a device which measures potential, right? Potential difference between any 2 points. It measures the potential difference between any 2 points. So when already we have a voltmeter, what is the purpose of the potentiometer? Now, potentiometer is the most accurate instrument we have to measure the potential, right, when compared with voltmeter. There are certain advantage of voltmeter, why we widely use voltmeter more compared to the potentiometer. But remember, potentiometer measures accurately potential when compared with voltmeter. So there is lot of accuracy in potentiometer when compared to the voltmeter, right? So our potentiometer is most widely used and most preferred device to measure the potential. But the problem with potentiometer is quite large in shape compared to the voltmeter. Voltmeter is what? It's very compact, it is very small in size, and easily you can carry in your pocket also if possible. But the potentiometer is a huge thing. It's when we compare with the voltmeter, again the same sort of meter bridge what you have seen. Okay, I'll tell you exactly how does it look. But the advantage of voltmeter here is it is compact, small in size, and one more advantage is it measures quickly. So result, it measures rapidly, or you get a result very soon. You might have seen, right, a typical voltmeter looks like this. It has certain reading, a pointer here, maybe 0.2 volt, 0.4, depending upon what kind of measurement it can does. So you just connect to the battery or any two portion of the wire, give a current, and within a fraction of second it will give you the readings. But the problem with potentiometer is, first of all, it is big in shape, it's large in shape, it is not a compact, it's not a small thing. Then plus you need to do certain arrangement, you need to connect circuit diagram properly, then you have to do the calculation, and then finally get the results. So by doing lot of calculation, by spending lot of time, then only you are going to get the value of potentiometer. So most of the people or most of the physicists will always prefer voltmeter over the potentiometer. But remember, potentiometer gives you results more accurately. The only reason is it do not withdraw any current from the circuit. So they may ask you a reason, give reason why we prefer potentiometer over voltmeter. Because the advantage of potentiometer is, first of all, it gives accurate result. And what is the purpose of giving accurate result is, it do not withdraw any current from the circuit when compared with the voltmeter. So today we are going to study what exactly is potentiometer, how does it look, what are the advantages of the potentiometer, and certain, because potentiometer you are going to perform two important experiments in your practical exam also. One will be the internal resistance of the cell, and another will be the comparison of the EMF of two cells. Both we are going to study in brief. Okay. So in exam they may ask you or they may not ask you this question. Okay, it's not that important. But from practical point of view, it is one of the most important experiment, because on potentiometer you are going to get two important experiment. So first of all, potentiometer, its principle. Okay, then later I will tell you how exactly it looks. So potentiometer, what it tells you, if I'll write, if a uniform cross-sectional wire carrying steady current, this is very important, carrying steady current I, then the potential drop, or the fall in the potential, then the potential drop across the portion, across the any portion of the wire is directly proportional to the length of the wire. And I am talking about the balancing length. You can remember in the meter bridge what exactly. So simple principle, what it states you, if a uniform cross sectional wire, remember the wire which I taken in the meter bridge, the same wire, maybe a magnesium or maybe constant, and you can take, because basically remember it should be an alloy, and I told you the conditions also. So if a uniform cross-sectional wire which is carrying a steady current I, then the potential drop or the fall in the potential across the any portion of the wire is directly proportional to the length of the wire. So what they are telling you is, the potential across any two portion of the wire will be directly proportional to the length of the wire. This length is the balancing length. I hope you remember the balancing length, where in the meter bridge I found the null point. Null point in the sense the galvanometer showed zero deflection, that is null point. Okay. So if you have not watched the previous video of the meter bridge, then it becomes very difficult to understand this concept, because this portion potentiometer is, most of the things are based on the meter bridge, and this is the continued part. So make sure ki you have seen that video. Okay. So what it tells you ki potential is directly proportional to the balancing length. So it's quite simple, right? You have to just find the balancing length. You have to make sure ki galvanometer does not deflect on the left hand side nor on the right hand side. Make sure ki galvanometer points towards the zero. Find that balancing length, and that balancing length itself gives you the potential. So this will be constant, which we usually write with phi and L. Okay, V equals to L. So if I want to find the potential difference across any cross-sectional wire, uniform cross-sectional wire, uniform, very important, then I will just find the balancing length. Clear? Okay. So we'll see how does a potentiometer looks and how it is different from the meter bridge, because both looks quite similar. There is a minor change here. So if you remember our meter bridge, we had taken a 1 meter wire or 100 centimeter wire. Here we are going to take a 4 meter ka wire, 4 meter or 400 centimeter. So again a wooden block, what we have taken in the meter bridge. Then here I had one terminal A. Now here there will be a directly terminal here, not on this side. and from here I'm going to take one wire. Okay, then I'm going to wind it, because 4-meter wire will be large, so this will be this kind of thing. Okay, and here there will be a plates, maybe a silver plate, or this is the wooden block, this is the wire, a 4-meter wire made up of magnesium or constant. Okay, fine. Now, which should be basically an alloy, and I told you ki you should take such wire that should be independent of the temp, or the resistance should be independent of temperature. So the condition here is, for an potentiometer you should take a 4-meter wire which should be an alloy. Make sure ki that wire's resistance should be independent of the temperature. Usually we prefer a magnesium or constant. Okay, now 4-meter wire becomes quite a big thing. So what we do here is we give him this kind of shape such that this will be of 1 meter. Now this, if you neglect the down part, this is my meter bridge itself. The only extra thing here is I am taking 4-meter wire. So this is 1 meter, this is one more meter, 3 meter and 4 meter. 1 meter, 2 meter, 3 meter and 4 meter. Okay, and then we'll connect with the desired equipment, whatever we want. We'll connect with the galvanometer and we'll find the balancing length. So if I get a balancing length at this point, then this is the potential V1. If I get at this point, this will be the potential. If I get at this point, this will be the potential. And correspondingly the scale will be attached to it, just how we have taken in the meter bridge itself. The scale is just to tell you accurate reading. Yes, okay. So I hope you have understood, you have differentiated between a meter bridge and the potentiometer. Quite similar, only thing is instead of 1-meter wire we are taking 4-meter wire. Now straight away we'll go with the application. Please remember the principle. So the first application of the potentiometer is to find to compare the EMF of two cells. First application, to compare EMF of two cells. Right. So there are two important applications of the potentiometer. First one is to compare the EMF of two cells, and another is to find the value of the internal resistance, of a cell. So first thing we'll study is compare the EMF of two cells. So in exam they may ask you what is potentiometer and explain how it is useful in finding the EMF of two cells. Okay, now if you have a situation like this, you have been given a two cells, and if I ask you which of the cell has more EMF in the sense which is more powerful, which is going to give me a more current. Okay, so and you don't have any device which can tell you which cell is good. So what will you do is you will be given a potentiometer, and potentiometer, what it does, it will compare the EMF of two cells, and it will tell you which cell is good and which cell is not so good. Okay, so first important application of the potentiometer is to compare the electromotive force. Already we discussed EMF of two cells. So you have been given two cells and your target is to compare the EMF of two cells, right? So again remember the principle. We are going to take a two cells. Simply we are going to connect to the potentiometer. First we will find balancing length of one cell, then second we will find balancing length of another cell. We will compare the length, and then length itself gives you the potential, right? So how we can do a circuit diagram? Look here. Again I will take a potentiometer, okay, A to B. Now every time when I draw the diagram, need not draw a 4-meter wire in this shape. We will assume that this is a long 4-meter wire. Okay, long 4-meter wire. This is the potentiometer made up of 4-meter wire. Now our aim is to compare the EMF of two cells. So first what I will do is I will connect this with the battery first. Then this is connected to the rheostat. Rheostat is a variable resistance. So this is my key. K1, and just write K, plug key, which acts like a switch. This is RH. RH is rheostat. Rheostat is again an electrical device which will give you variable resistance. You can vary the resistance as per you want. You can regulate the potential and as well as you can regulate the current. Rheostat will provide you what? Variable resistance. And this is as usual my battery, which is carrying a steady current I. Make sure ki our this wire is a uniform cross sectional wire, so that there should be not a variation in the resistance, because you know resistance inversely depends upon the cross sectional area and directly upon the length of the wire. So what I will do here is, now I will connect this with two cells. This is my cell E1 and this is my cell E2. So now I cannot simultaneously compare both the cell at once. So in order to avoid that confusion, now see here both are competing. They want to prove ki who is great, who has more EMF. We have two cells E1 and E2 and our task is to compare their EMF. I am not sure what is the EMF of the cell. So what I do is I simply take a potentiometer, a 4-meter wire connected with the board, connected with the battery, and I'll put them into a competition. So now I cannot simultaneously judge this both cells at once. So in order to avoid that, I'm going to use one special kind of key which is known as a two-way key. So till now we were studying just a single key, plug key. Key, what it does, it just regulates on and off. Okay. So now I'm using this special kind of key which is two-way key. Now two-way key has 3 terminals. Unlike our regular key which has just 2 terminals, this has 3 terminals. So now there is a dispute between both the cells and they want to know who is great, whose EMF is higher. So we are going to appoint one judge here. So who is going to judge here is the galvanometer. Here we are going to connect with the galvanometer. And you know galvanometer again, it has 2 terminals. One terminal will come either from E1 or E2 and another terminal is connected to the sliding contact, or it is jockey. Sliding contact, I told you, it's a metal made with a knife edge thing so that it will find that balancing length. Is that clear? Okay. So this is what a typical potentiometer looks like, and this is how we are going to set up our experiment to find the compare the EMF of two cells. Let me recall, a potentiometer connected with battery. This portion, this circuit is known as a primary circuit, a basic circuit, and this circuit, this much part, is known as secondary circuit. Is that clear? Okay. Now please draw the diagram so that we will calculate the things and we'll see how we get this. Okay. Now how we are going to start this experiment. Now first thing is, I am interested to find what is EMF of this cell. So what I will do here is, this key I will open. See here, it has switch, it has 3 switch. Okay, I will open this key so that this circuit becomes open, and whenever there is an open circuit, no current will flow through this part. Whatever current is flowing, that will flow only through this cell. As a result, galvanometer will deflect. Now what I will do, I will take a sliding contact and place it here. You will find that galvanometer is deflected here. Again I will take my galvanometer and placed at extreme right hand side so that it would have deflected here. But what I want is, I neither want my galvanometer to deflect here nor it should deflect here. I should adjust my galvanometer in such a way that I should bring it exactly at the 0. Because you know, I told you galvanometer 0, it will be here. On either side there will be 30 divisions. So when I place it here, it has deflected here. When I place it here, it has deflected here. So it is quite obvious that somewhere in the middle, it has gone through that 0. And I am interested to find where is that point 0. So what I will do is, I slowly start moving my hand from point A to B. and as a result what I find here is slowly the galvanometer is also coming towards the zero. So somewhere here at this point C, I find that my galvanometer has pointed towards the zero. So I will take a scale. Already the scale will be installed here. I'll just measure this length. I'll give a name as L1. L1 indicates the balancing length of cell E1. Now second case, when I want to find the balancing length of E2, what I will do, I'll simply open this circuit and I will close this both. What I am doing here is I am not allowing the current to flow through the circuit, and whatever key I have taken it from this side, now again I am plugging it here so that current will flow through this circuit. Again same thing, I'll place it here, deflection here, I'll place it here, deflection here. So again I'll slowly move and I may get a point here, somewhere here, and now I'll measure this length and give a name as L2. Now just a simple example you find here is L1 is quite smaller and L2 is quite big. Okay, it's large. L2 length is much more larger and L1 is small. So here what you see is L2 is big. What it indicates, the EMF also will be the larger in size, larger compared to the EMF of the first cell. So what I am doing is simply I am taking a sliding contact, finding the balancing length, and the balancing length itself tells me the potential difference across this cell. So simple logic, just connect it, take a galvanometer, connect with the sliding contact and find the balancing length. Whatever balancing length you get, that itself is the EMF of the cell. Yes or no, students? Okay, so here I have got L1 and L2. So so I have understood what is the purpose of two-way key also, right? Now what I found here is principal told me, the principal of the experiment told me ki balancing length is directly proportional to the EMF of the cell, that is E1 is proportional to L1. So here, and E2 is proportional to L2. So here if I remove this proportionality, make it constant phi, L1, and here E2 will be what? L2. Is it clear? Okay. So here E1 by E2, I am comparing this, I should take ratio. So phi gets cancelled. So what will be here? L1 by L2. And this is my experiment. So simply find the balancing length L1 here and balancing length L2. Again balancing length is the null point, and compare the EMF of two cells. So this is the simple experiment that you can expect in your exam. Okay, have you understood potentiometer? Okay, so now we are going to study one more important application, that is how to find the internal resistance of the cell. Okay, is that clear? Will you remember the diagram, principle, and the theoretical part? It's quite easy, simple. Is that clear? Have you understood? Okay, now second important application is to find the internal resistance of the cell. To find the internal resistance of the cell. So second important application is find internal resistance of the cell. I hope you remember this, which was denoted by small r. So it is the resistance offered by the cell itself. Okay, so the concept of electromotive force came into existence. So now again, instead of two cells, you have been given one cell, and your task is to find the value of the internal resistance of that cell. So how you are going to do it? You have been provided with the potentiometer. So potentiometer will do this work for you. So again, take a simple potentiometer. Simple potentiometer. It has just two terminals, point A, point B. It has a 4 meter wire. Okay, so again what I am going to do here is I am going to connect with the battery. Battery will, with the rheostat variable resistance, it will regulate the potential and current. Once you do the practical, the things will be quite clear to you. Okay, so don't mind if few things are going a bouncer to you. Okay, because once you do the practical, things will be quite clear, you will understand. So again, this is my battery, a rheostat, a key. I'll give a key K1 plus minus. So current I is flowing. Okay. This is 4-meter wire. Okay. 4-meter wire. I need not show you. You will understand. Okay. Now students, how to do this? From here I will connect with resistance box, and here is my cell, plus minus. I will connect with lucky, and here will be my galvanometer. Okay. Find the balancing length. Okay, students. Now please look carefully here. Again, this is my potentiometer. Again, recall the first diagram itself. Okay, it's a 4-meter wire in a zigzag shape, but just to what is that? To do in a compact way, I'm just showing in a straight wire. Okay, a wire, 4-meter wire, potentiometer connected with the battery rheostat. This compromises of a primary circuit, basic circuit, and this compromise of a secondary circuit. Secondary circuit. So now again there is my cell having certain EMF E, and I am interested to find what is the internal resistance of this cell. So to find the internal resistance, I am simply again connected to the potentiometer. So again what I am going to do here is, first again I have two keys now, K1 and K2. First what will I do? I will keep this open, and I'll K1 I'll close it. So I am allowing the current to flow only through this circuit. I am just allowing the current to flow through this circuit. Are you understanding, students? So no current is flowing through this cell, because no current is being generated through this cell. Whatever current is flowing through the circuit, that is again calculated by the detected by the galvanometer. So again I'll check the opposite side deflection. Again, you know the same thing, galvanometer deflect on the left hand side, again it will deflect on the right hand side. I will slowly find the balancing length L1. Imagine I got the balancing point here, so this will be L1. Now this balancing length L1 is because of our primary circuit. Okay, now second what will I do here is, I will close both K1 and K2. I'll close both K1 and K2, because if you remember internal resistance, at least you know this, I equals to what? E divided by R plus R. So what is this I? I is the current through the cell. It depends upon external resistance R and internal resistance R, small r. Okay. So first thing is very important to note down the balancing length L1 due to primary circuit. Now second, I will close K2. Now whatever current is flowing, that current is flowing through this secondary circuit. Then again I will find the balancing length. I may get somewhere here, and I will give a name as L2. But most of the time you will find ki balancing length due to cell will be usually lower, because battery has a potential of maybe up to 12 volts, and our cell may hardly give up to 3 volts. So it is quite obvious ki balancing length of the cell will be smaller. Not most of the time, depends upon the what kind of battery also again you're using, and what kind of cell also you're using. So imagine for my instant, if I get a balancing length here, I'll measure this as L2. So are you understanding the arrangement? A potentiometer, a 4-meter wire connected with one primary circuit and connected with the secondary circuit. Primary circuit connected with the battery, secondary circuit connected with the cell. First I will open the K2. Okay, so that no current will flow through the secondary circuit. I'll find the balancing length, I'll measure it and give a name as L1. Now what I'll do, I'll close this. I will find again balancing length, opposite side deflection, find the balancing length and note it down. Now we will see how exactly to find the internal resistance using both L1 and L2. Have you understood this arrangement? Okay. A little bit difficult to imagine because you have never seen potentiometer in your life. But once you do the practicals, trust me, things will be quite clear and very easy to understand. So try to visualize and imagine the things. Okay. Okay. Now when K2 is open, K2 is open and K1 is closed. So current is flowing through primary circuit. Current is flowing through primary circuit. So here E1 will be what? Equals to phi L1. Yes or no? Similarly, when K2 and K1 is closed, then potential through a cell will be what? Phi equals to L2. This is equation 1 and this is equation 2. Are you understanding? So this is for my primary circuit and this is for secondary circuit. Okay. So this is the net potential across the whole circuit. Okay. So E1 equals to phi. I'll just give now E because we don't have two cells. E equals to phi L1, V equals to phi L2. This is due to the cell and the battery. Here this is only due to the battery, which is the primary circuit. Now again, if I compare this, E by V equals to L1 by L2. Yes or no? Because phi gets cancelled. Phi gets cancelled. So you know what is V equals to? V equals to IR. And what is current through cell? It will be I will be equals to E divided by R plus R into this R. Yes or no, students? Can you recall the things which we have already studied in EMF, terminal potential difference and internal resistance of the cell? I equals to E divided by R plus R and this R. Are you understanding? So what will I do here is, instead of writing V, I will write V equals to E divided by, again divided by R plus R into R. Right? So instead of V, I have simply equated this thing. So from this I can cut E with E. Right? So what will be here? This will be again L1 by L2. L1 by L2. I'll erase this. Okay, you can write a reason here. V equals to IR if you want. E divided by R plus R and this R. Here V equals to. This you can write. Now I have cut E with E. What I am left here with R by R plus R. Now this is denominator of denominator. Denominator should be shifted to the numerator. So this becomes R plus R divided by R, L1 minus L2. Again, capital R is the external resistance, small r is the internal resistance of the cell. So again I will separately divide them so that R gets cancelled. So this will be what? 1 plus R divided by R. Are you, can you do this? R I have cancelled. I have separately divided this R by R. So this will be what? L1 by L2. So R will be from this. I'll multiply R here and this will be L1 by L2 minus 1. I have shifted this plus 1 on this side. So this will become minus 1. So look here how easy it is to find the internal resistance of the cell by just making use of the potentiometer. Just take a cell, find the balancing length and just equate, substitute in the formula and get the things. Where R is the external resistance that you can control. Wherever we have used the resistance box, whatever desired resistance you want to provide, you can provide, and just you should know the value of L1 and L2. L1 and L2 will be given by the galvanometer by finding the null point. That is the balancing point. So this R is the internal resistance which you can get by this formula. So R equals to capital R into the bracket L1 by L2 minus 1. Okay. So this concludes your entire current electricity topic, which will comprise of totally 13 marks. So one of the most important topic. So I hope you have followed all the lectures, okay, of this topic. So from next class onwards, we are going to start a new chapter, that is moving charges and magnetism. Okay. So till now, bye. Okay. Till then, bye.